In section 7.6, we're looking at proportions and problem solving with rational equations. Our objectives are to solve proportions, use proportions to solve problems about numbers, work, and distance. When solving a proportion in the form of two fractions that are equal to each other, one way to solve these types of equations is by cross-multiplying. So if you have the equation in the form of a over b is equal to c over d, then you can cross-multiply, multiply across, and those products are equal to get a times d is equal to b times c. And that's what we'll do for these examples. Since we have x divided by 39 equals 6 divided by 13, we can cross-multiply to get 13 times x is equal to 6 times 39, or 13x is equal to 234. By dividing both sides by 13, we see that x is equal to 18. And as always, when you're solving equations, you want to check your answers by plugging in your value back into the original equation for x to get 18 over 39 is equal to 6 over 13. And these two are equivalent fractions, so our answer is x equals 18. Let's repeat the steps for example B, where we have 2 over 7 equals 5 over x. Because we have a proportion, a over b equals c over d, we can cross-multiply to solve this equation. When we cross-multiply 2 times x, we get 2x and equals 5 times 7, or 35. By dividing both sides by 2, we get our answer, x is equal to 35 over 2. As always, we want to check our work by plugging that value back into the original equation. So it's 2 over 7 equal to 5 divided by 35 over 2. And since these are equivalent fractions, we know that our answer is 35 over 2. There are 170 calories in 3 peanut butter cookies. How many calories are in 7 cookies? We can set up a proportion to solve this type of equation, this type of word problem, where we have identified the two variables, one being calories. So the calories over the number of cookies in the first example is going to equal the same number proportion in terms of the calories over the number of cookies. So first, we're given that there are 170 calories in 3 cookies. So on the left side, our fraction is 170 over 3. And that should equal the number of calories that are in 7 cookies. So on the right side, we get equals x over 7. So this proportion can be solved to find x, the number of calories in 7 cookies. By cross-multiplying, we see that we get 170 times 7 is equal to 3x. And 170 times 7 is 1,190 is equal to 3x. By dividing by 3, we see that x is equal to 396.7, and that is the number of calories that you will have in 7 cookies. We can also use proportions to find the lengths of similar triangles. In this case, our proportion we'll set up is using the length of the little triangle over the length of the big triangle. The corresponding sides is going to equal the length of the little side of the triangle over the length of the side of the big triangle, making sure that we're using the similar sides of the similar triangles. So we could set up this proportion as the little two that we do know. One is 21 over the corresponding 27 on the big triangle. And for the little triangle, we have the side of 28, and x is a similar side on the larger triangle. You could also set up the proportion using the other side with 14 on the smaller triangle and 18 in the bigger triangle, and that will equal the proportion of 28 in the smaller triangle over x in the bigger triangle. You can solve either one of these for x to get the length of the missing side. So if we multiply using the cross multiplication for this proportion, we see that we get 14 times x, or 14 times x is equal to 28 times 18. And 14 times x is equal to 504. And then by dividing both sides by 14, we get x is equal to 36. So the length of the missing side of the larger similar triangle is 36. Let's set up a proportion to solve this word problem. 5 divided by the difference of a number and 1 equals the quotient of 10 and the sum of the number and 12. Find the number. We are translating the written words in the sentence to the algebraic expressions. 5 divided by the difference of a number and 1. So that's going to be written as 5 divided by x minus 1 equals the quotient. Now quotient is a division, so it's a quotient of 10 and the sum of the number and 12. Our proportion is 5 over x minus 1 equals 10 over x plus 12. We can cross multiply to solve this proportion and get 5 times the quantity x plus 12 is equal to 10 times the quantity x minus 1. By distributing, we get 5x plus 60 is equal to 10x minus 10. We can subtract 60 from both sides of the equation and subtract 10x from both sides of the equation to get negative 5x is equal to negative 70. We can then divide both sides by negative 5 to get x equals 14. So we can check this in our original proportion that we set up. Since x is equal to 14, we can do our check step. 5 divided by 14 minus 1 is equal to 10 divided by 14 plus 12. So that's the same thing as 5 over 13 is equal to 10 over 26. Since these are equivalent fractions, we know that our answer is correct. Let's use a proportion to solve this word problem. If 3 times a number added to 5 is divided by the number plus 9, the result is 4/3. Find the number. We're going to translate the written words in the sentence into the algebraic equation. 3 times a number is 3x added to 5 plus 5. When that is divided by the number plus 9, x plus 9, the result, that means it's equal to 4/3. We can solve this proportion by cross multiplying to get 3 times the quantity 3x plus 5 is equal to 4 times the quantity x plus 9. By using the distributive property, we get 9x plus 15 is equal to 4x plus 36. Then by subtracting 4x from both sides and subtracting 15 from both sides, we get 5x is equal to 21. And then by dividing both sides by 5, we get x is equal to 21 over 5. As always, we should check our answers by replacing the x in the original equation with our answer, 21 over 5. So we get 3 times 21 over 5 plus 5 in the numerator over 21 over 5 plus 9. Does that equal 4/3? By simplifying, we see that the numerator here is 17.6 divided by 13.2, and that is equivalent to 4 over 3. So we know that our answer, x equals 21 over 5, is correct. A painter can paint a sign in 4 hours. His assistant can paint the same sign in 6 hours. How long will it take them to paint the sign if they paint it together? Now, there are many approaches to solving these types of work problems, and I like to use the method of using the distance equals rate times time, where d is the distance, r is the rate, and t is the time. Now this is typically involving problems about distance, but we can apply this to work problems as well, where distance instead of d for distance is going to be the number of signs, r is the rate, and t is the time. So for the painter, the distance is equal to the rate times the time. The distance is actually one sign is equal to the rate times the time of 4 hours. So the painter's rate is equal to 1 over 4. That's one sign in 4 hours. So that's the rate for the painter. The rate for the assistant is one sign times the rate for every 6 hours. So the rate for the assistant, I'm going to use little subscripts here, is one sign every 6 hours. Now we can add those together times the time to determine how long it will take to paint an entire sign together. So that is going to be the rate of 1/4 times the time for the painter, and then the rate for the assistant is 1/6 times the time, and that's going to equal one whole sign. So 1/4 t plus 1/6 t is equal to 1. By adding those together, we get 5t over 12 is equal to 1. 1/4 plus 1/6 is equal to 5/12. Now we can multiply by 12 to get 5t is equal to 12, and then by dividing by 5, we get t is equal to 12 over 5, which is 2.4 hours. So it should make sense that if they work together, they can paint it a lot quicker than working on their own. If the painter paints it in 4 hours and the assistant paints it in 6 hours, if they work together, it's only going to take them 2.4 hours to get the whole job done. A conveyor belt can move 1,000 cans of soup to the loading area in 7 minutes. A smaller conveyor belt can move the same number of cans in 11 minutes. How long will it take to move 1,000 cans of soup if both the conveyor belts are used? This is a similar type of problem to what we just did with painting the sign. Here we're looking at distance, or d, being the number of cans, r is the rate, and t is the time. So we can think of this again as a distance is equal to rate times time. Let's look at the first conveyor belt. Can move 1,000 cans in 7 minutes. So 1,000 is equal to r times 7, or the rate for that conveyor belt is 1,000 divided by 7. For the smaller conveyor belt, it can move 1,000 cans in 11 minutes. So the rate for the smaller conveyor belt is 1,000 divided by 11. We can use subscripts to denote the difference here. Now, if we take each rate times the time, we want to know how long it will take to load the 1,000 cans if both conveyor belts are used. So we can set up the equation as 1,000 over 7 times the time plus 1,000 over 11 times the time. That's distance equals rate times time for the small and the big. And that we want to know how long it will take them both to move 1,000 cans of soup. So we end up with this equation. By adding those two like terms together on the left side of the equation, we get 1,000 over 7t plus 1,000 over 11t. By adding those fractions together, we get 18,000 divided by 77t is equal to 1,000. By multiplying both sides by 77, we get 18,000 t is equal to 77,000. And then by dividing by 18,000, we get t is equal to 4.27. And this is going to be in minutes. So it makes sense that if the first conveyor belt takes 7 minutes to load and the smaller one takes 11 minutes to load, if they're both used together, then it should load much quicker. So the time is 4.27 minutes. A cyclist bikes at a constant speed for 18 miles. His return trip is a different route of 23 miles and will take 1 hour longer. Find the speed. We're assuming that he's riding at the same speed in both directions. So we can use a distance equals rate times time to set up a table here where d is distance is equal to rate times the time. And we want to look at both the one-way trip and then the return trip. So the distance he goes to begin with is 18 miles, and his return trip is 23 miles. Now we don't know what the rate is, but we know that the time, it takes 1 hour longer for the return trip. So we can use a variable x to represent the time, and then x plus 1 to represent the return time. So if we know that distance is equal to rate times time, then rate is equal to the distance divided by the time. So the rate for the first trip is going to be the distance of 18 divided by the time x, or 18 over x. And on the return trip, the rate is equal to the distance of 23 divided by x plus 1. So that's 23 over x plus 1. So these rates are going to be the same, and we can set up a proportion to find the solution. So we want the rates to be the same. 18 over x, that's the rate at the first half of the trip, and then the return trip, the rate is 23 over x plus 1. We can solve this proportion by cross-multiplying to get 18 times x plus 1 equals 23 times x, and then by distributing, we get 18x plus 18 is equal to 23x. And then by subtracting 18x from both sides, we get 18 is equal to 5x. And then finally, by dividing both sides by 5, we get x is equal to 18 over 5, which is 3.6. So 3.6 is actually the number of hours that it takes on the first half of the trip, and then the x plus 1 would be an additional hour returning 4.6 hours. So then we can look at the rate. The rate is equal to the distance divided by the time, or 18 divided by 3.6, which gives us 5 miles per hour. So our answer is written as 5 miles per hour.